Okay, so today we're going to look at what do you do if you have functions that are defined by x. Okay, so we're looking at f of y and g of y. So you'll want to cut this little graph out and then probably stop the video and copy these notes. Um, and I want you to look at what they want. So they want this area between 3 minus y squared, that's this, and the line x equals y plus 1. Okay, so we're finding this area right here. So it may seem like, well, why do we have to change it? Why can't we just do this the same way we've been doing? And the problem comes up, well, actually, sometimes you'll see we can do some of them either way, but the problem comes up if I try to subtract this one from this one, because right in here, it would work right up to here. Now over here, I've got a parabola, and it's the same function both places. Um, we could do it, it would just be a really big pain, okay? So I want you to think about, well, what if we just flip that around? Okay, then that's exactly what we did before. We would take the parabola minus the line. Okay, and we can see that clearly the parabola is on top, and nice and simple. Now, when you're doing this and you're trying to decide whether you should, go with respect to y or with respect to x, you always look at right minus left. And you'll see that when we do some stuff with volumes, it can get confusing because the formulas are really similar. And so I want you to remember that we always go this minus that. Okay, like that's our general way of doing it. As opposed to this minus that. And again, I want you to think about it because it looks like that. Okay? All right, so just like before, the first thing you're going to do is you're going to find the points of intersection. Now, this particular one is solved for x. Sometimes we have to go ahead and do that. Okay, so I'm just going to say, well, where is 3 minus y squared equal to y plus 1? And I'll get 0 is y squared plus y minus 2. So y plus 2, y minus 1 is 0. Okay, so we want to prove that if we're doing this by hand. So we can see it right here that this is at negative 2 and this is at 1. Okay, so we're looking on the y-axis now. Okay, so we're going 1, like going this way. Okay, so those are our bounds of integration. Okay, so now let's go ahead and set up our integral. So we're going to go from negative 2 to 1, and I'm going to put in 3 minus y squared minus y plus 1. So just always watch that negative right there. That's just an easy place to make a mistake. Okay, now I'm integrating with respect to y, so now I have a dy there. Okay, so that's going to equal, I'll just put it over here, from negative 2 to 1 of negative y squared minus y plus 2 dy. Okay, so easy peasy lemon squeezy. So we're going to get y cubed over 3 minus y squared over 2 plus 2y, and we're going to evaluate that at 1 and negative 2. Okay, you can go through all that work if you would like to, but I will just tell you it is going to equal 9/2. Okay, so that's it if it goes sideways. Okay, let's look at a different one. Okay, so let's say we have y squared is 4 plus x, and y squared plus x equals 2. Okay, so this is one that I might cheat a little bit on my calculator to see what this is going to look like. So I'm going to solve each of these for y. Okay, so over here, watch what happens when I go y squared is 4 plus x. So y is plus or minus the square root of 4 plus x. So that plus or minus is going to be really important. Okay, y squared is 2 minus x. So y is plus or minus the square root. Okay, so when you put that in your calculator, okay, notice how I had to put that in. And I could change this so that they all have the same color. Let's see. I'll make that, if I even remember how to do it. I think that's right. No. Okay, I'm not going to fiddle with that, but I know I can make them the same color. Okay, so now when I graph them, okay, it's going to come out in different colors on this calculator. And it looks like that. Okay, so we're going to find the area right in there. Okay, so notice if I went with respect to x, you know, I could do it, but then I have this one minus that one. I have the plus or minuses, and it's easier if I just think about it like this. And I'm just going to do this one minus this one, okay? So first thing I'm going to do is I'm going to get a little sketch. And you know, some of these, I don't care if you use your calculator to sketch them. And let me see. No, I didn't make that very good, but we'll get the general idea. Okay, so it's going to look like that. Okay, so I've got to find these points of intersection right here. And it looks like I didn't draw mine very well because they look like they're a little bit over, again the lighting, a little bit over to the left there. Okay, so these are each y squared. So I can just say, well, where does 4 plus x equal 2 minus x? Or, wait. What do I want to do here? Oh, duh. I'm going to solve both of these for x because I'm going to do it on the around the y. Okay, so I'm going to get this first equation that x equals y squared minus 4. And this one I'm going to say x equals 2 minus y squared. Okay, so that's the key, that we solve for x if we're going to go around the y-axis. Okay, so now when I look for the point of intersection, I'm going to say y squared minus 4 equals 2 minus y squared. Okay, so we're going to end up with 2y squared equals 6, y squared equals 3, and y equals plus or minus the square root of 3. Okay, so that's going to be our bounds of integration right there. Okay, and we're going to go right minus left. So this was the top one here, was this one over here. Okay, always right minus left. Okay, so now I'm going to go negative square root of 3 to the square root of 3, 2 minus y squared minus y squared minus 4. Okay, I think I put the right ones in the right order. And I think I just messed you up before with which one is which. Okay, so this is going to become the integral from negative radical 3 to radical 3 of 6 minus 2y squared dy. So we're going to get 6y minus 2y cubed over 3 evaluated at negative radical 3 to radical 3. And again, you can work that all out, but you will get that. Oops. Okie dokie.